Hey, what's up, everybody? All right, so today we are going to be going over the periodic table. All right, so periodic table is one of the most organized things I've ever seen. All right, but how do you read it? Let's dive into it. All right, so this is the periodic table. It's a lot to see at first, but if you know what you're looking for and you understand this table, it's going to be awesome. You're going to understand exactly why everything's a different color, all the numbers are there, all that good stuff. So let's look at it. So to read the table, you start reading from left to right. So number one is right here, number two, three, four, five, six, and then you just keep going left to right. When you look from left to right, the elements are increasing, all right? Vertically, it shows you different groupings. The same colors all mean that they're part of the same family. Each row, which is left to right as you normally read, that means they have the same atomic orbital. So row 1 or row 3 has the same orbital. Gaps exist due to their atomic number. And then the bottom two rows are rare earth elements. These two right here, the lanthanoids and actinoids. Let's look more closely into it because this is just kind of introducing you to the topic, and then we'll look in greater detail. So when you're reading from left to right or left to right, I got to do it reverse for me so you guys can see it. But the elements are increasing based off of their atomic number. All right, so the atomic number is the number up top, and that just means how many protons are in the nucleus. Okay, so protons are found inside the atom, and those are found with neutrons, and then the electrons are the ones that circle out around it. Atomic number is protons, so that's it. And then the atomic mass is how many protons and neutrons are in the nucleus. So it counts both. Um, the atomic mass or the atomic weight is how many are in that specific element just together. And that also increases from left to right. So atomic mass goes up as you're reading left to right, and so does the atomic number. When you're reading top to bottom, it shows different groupings for elements. So we got your alkali metals, alkali earth metals, transition metals, lanthanides, actinides, noble gases, halogens, all transition metal, bunch of different stuff. All right, so each element belongs to only one color, except for hydrogen. Hydrogen can be a halogen, which is the red ones right over here, and it can also be an alkali metals, where it's found over here. So that one has the ability to go back and forth. Only one that can do that. So um, if anyone asks or anything, only hydrogen can be a part of two families. But um, this is a way to understand it. So we got alkali metals, alkaline metals, rare earth elements over here. In the middle, transition metals, other metals, um, metalloids, nonmetals, halogens, and then the noble gases. So you will sometimes need to understand this, but for all intents and purposes, when you're working with the periodic table, it's just you're going to be searching for it. So you just have to know where to look and what you're looking for. So these are all of the families. Families and groupings are the same things from top to bottom. The only thing with the transition metals is that it's a lot bigger than normal. All right, so it covers a chunk of the periodic table. So we got the alkali, alkaline, boron has its own family. Carbon, nitrogen, oxygen have their same stuff, and then halogens and the noble gas family. Then there's lanthanides and actinides. So make sure you understand this when looking at stuff. Each letter there's going to be another video going into what the letters mean and kind of breaking down all of the elements, but they all stand for a different element. So He is helium. um, there's a bunch of them. Ne for what I think it's neon, something like that. But we're gonna dive into it. Okay, I'll be fully honest with you, I'm not amazing at science or chemistry, but I'm gonna try my best to break it down for you guys to fully understand this so you're passing the test. Okay. So when you're reading rows, that's from left to right, and these are also called periods. All right, reading across is a period, so left to right, as you normally do, where it's increasing in the atomic number and the atomic mass. All of the numbers in a period have the same orbital. That just means where the electrons are found in an atom. So in period 3, that means there's 3 orbitals. All right, that's how many circles are around the element. So period 5 would also have 5 orbitals. There's a maximum of 7 periods. There can only be a max 7 orbitals. So that's in case someone's like, look at period 9. There is no period 9. It's only 7. All right. So for numbers 6 and 7 right over here at the bottom, these can sort of attach themselves right here. So like um, 58, like 57 starts here and then it goes down to here, 58, 59, 60. It goes up to 71 and then meets it here at 72. The reason it's at the bottom is because they're different they're different families, and I believe their atomic mass is different. Or no, I don't think it is, but it's because they're different families, so they wouldn't be a part of the transition metals. So they're organized at the bottom. So on the topic of metal, you need to know your metal. All right, all of the elements are classified into 3 types of metal. You got your metals, actual metals, right? 2 is metalloids, almost metals, and then 3, no metals, non-metals. So metals are to the left, to the right are the non-metals, and then in between are the metalloids. So we got metals, non-metals, or metal. I don't know. You know what I'm talking about. Look to the left, that's metals. Look to the right, that's non-metals. In the middle, it's metalloids. So this is exactly what I mean. So to the left, all of this red is metal. To the right is all non-metals, and then hydrogen, of course, flops back and forth, so it's a non-metal, and then metalloids right here in the middle. To classify this, all right, metals are they have luster, which means they're shiny. They reflect light. They are also solid at room temperature. They can conduct heat and electricity, and are malleable. Malleable just means it can be shaped or changed. So if something's malleable, you can break it down. It's like, think of it like Play-Doh or something like that, right? Um, Metalloids have a mixture of these properties, but let's dive into nonmetals first, so you can understand it. They lack luster. They aren't as shiny. They don't have all of that good stuff. They do not conduct heat or electricity, and are non-malleable, so they cannot be shaped or changed. So if you took a hammer to it, or well, if you can break it with a hammer, it's malleable. All right. If you can't do that, it's non-malleable. So like gases, those are something that you can't shape or change. So like if you see air, you can't just grab it and be like, oh, all right, let me change it real quick. You can't do that. All right. They may become a solid or liquid at certain temperatures, but at room temperature, just straight up like normal, they can't be changed. So metalloids can be a mixture of the two. So they can be shiny and have that luster, but maybe they aren't malleable. Those would be the metalloids. So you'll see more of that. We'll talk more about the elements in a different video. But for now, this is all just periodic table stuff, right? So let's do a quick little learning check. Now that you know how to read a periodic table, that's all we're doing, understanding exactly how it's organized, how to do it, how to read it. I want you to name the element in the second period that is also a noble gas. So you'll have to go back and probably understand how to do that. Um, what are the differences between a metal and a nonmetal? What is an atomic mass? Reading from top to bottom identifies what and which element can be a part of 2 groups. So go ahead and answer this stuff. Submit your notes to me, and then let's see if you understand how to perfectly read the table. Again, I apologize for not knowing everything about science and chemistry, but we're going to work on it together. We can pass this stuff together, all right? That's what it's all about. So just answer these questions, submit it to me, and you'll be good to go. So thank you so much for watching. I hope you have a great rest of your day.